The next type of reaction we're going to look at in aqueous solution are called oxidation-reduction reactions. And these reactions involve electron transfer from one reactant to another. And we call these type of reactions oxidation reduction or redox reactions for short. So this section is going to focus on redox reactions that contain metals. So what we need to do first is define oxidation and define reduction. So oxidation can be defined as the loss of electrons by a substance, where reduction is the gain of electrons by a substance. You may have heard the term oil rig, which stands for oxidation is losing and reduction is gaining, and this is in terms of the electrons that are transferred between the reactants. So we need some type of way to keep track of all of these electrons that are moving around in these reactions. So we come up with a term called oxidation numbers. And oxidation numbers are going to follow some type of set of rules so we can analyze these reactions a little more deeply. And I will say that when we look at electrons, they cannot be created or destroyed. So oxidation cannot occur without reduction, and reduction cannot occur without oxidation. So these oxidation numbers are going to allow us to come up with some rules to keep track of all these, of everything that's going on. So an oxidation number, or it's sometimes referred to as an oxidation state of an atom, is a hypothetical charge assigned using a set of rules. So let's go over all of these rules. Rule number 1, the oxidation number of an element in its elemental form is 0. Examples of these are H2, O2, P4, iron, gold, etc. In each of these cases, the hydrogen, the oxygen, the phosphorus, the iron, and the gold, their oxidation number is going to be 0. Rule number 2. The oxidation number of a monatomic ion is its charge. So, for example, sodium plus is going to have an oxidation number of +1. Magnesium 2 plus has an oxidation number of +2. Cl minus has an oxidation state of -1, and S2 minus has an oxidation state of -2. So if we look at the periodic table, the group 1A and the group 2A elements are going to have a +1 or a +2 charge, whereas the group 6A and 7A are going to have oxidation states of -2 and -1 respectively. So The next rule is going to look at if we have a bunch of elements together in a compound. So rule number 3 is the sum of oxidation numbers of atoms in a compound is 0. So when the compound is formed, we have a sum of all of these oxidation numbers equaling 0. So for example, if we have magnesium nitride, which is Mg3N2, we have to have the total oxidation number for this particular compound to add up to 0. There are 3 magnesium 2 pluses, and we know that magnesium 2 plus has a charge of +2. There are 2 nitrogens. We don't know what that oxidation state is, so we're just going to call this X. And the sum of all of these has to equal 0. So if we do some algebra, it's going to be 6 plus 2x is going to be equal to 0. This is going to give us 2x is equal to -6. And x is going to equal -3. And the -3 then would be the oxidation state, or the oxidation number, for the nitrogen. So that's what you need to do if you have a particular compound. You got to add up all the oxidation states, and it's going to be 0. That doesn't matter if the compound has 2, 3, 4, 5, or 6 different elements in it. That's what you'll have to do for those compounds.